Okay, problem-solving strategies for applied minimum and maximum problems. Pretty much there, if you follow these 5 rules, makes it a little bit easier. Assign symbols to given quantities and quantities to be determined. This is pretty important, especially on the AP, that you define everything, okay? When feasible, make a sketch. I always find that a picture helps. Write a primary equation for the quantity that is being maximized. Read the question and see, they're going to give you all this information. Go to the very last question and say to yourself, what do they want? What do they want? That's the formula. Reduce the primary equation to having a single independent variable. For example, when you write down length times width times height, there's 3 variables. You want it in 1 variable. This may involve the use of secondary equations relating independent variables of the primary equation. When we talk about secondary equations, sometimes they have to do with proportion, sometimes they have to do with other information that they give you. Differentiate the equation and solve for the critical values. First derivative, max and mins. Determine the desired maximum minimum value depending on the situation. All right, here we go. A manufacturer wants to design an open box, having a square base and a surface area of 108 square inches. What are the dimensions will produce a box with maximum volume? They've already given us the surface area of the box. This is the base, and because this is X right there, and that's H, this is 4 because we got 4 sides to our box, okay? We want the maximum value. So right now, what formula do I want to maximize?
A prism.
Yeah, or this box right here, all right? And what, using these symbols, what is the volume of this box? X squared times H. That gives me the volume of this box. Not quite. I cannot take the derivative yet because I need a single independent variable. I have, what 2 variables do I have? X and H. I only want what variable? Probably. Probably just X. All right. So you go back to the equation and you ask yourself, what other information did they give me?
4. They gave you 108.
And that is the what?
Surface area.
That's the surface area. So what we do is we go back down here.
By 6?
I'm sorry, what? Say that again? What did you say?
6 sides to a cube.
And this, it's open top, so we're not counting the top. Okay? And there are 4 sides, and the base is a square. We got it. Okay? Are we
I
good?
never would have known that there was not, there was an open box.
No, they specified it in the problem.
No, I know,
You
but
take-
like, I wouldn't have guessed.
Oh, okay. So we have X squared.
1, 2, 3.
Oh, no, I thought you were about to say.
Okay. What variable am I trying to get rid of in my volume equation?
H.
H. This is the one. So what variable do I need to solve for down here? H. I need to solve for H so that whatever H equals, I can put it in my equation. How do I go about solving for H?
Minus X squared.
All right. Yep, 108 minus X squared, divide by 4X. That gives me my H. Put this in for that one right there. Now, this is going to require an understanding of algebra and reducing. Be very careful. All right. Okay. What can I now cancel and reduce?
Probably 108 divided by
Nope. You cannot just divide the 108 by 4 because it's separated by a subtraction. I'm just saying all of this is being multiplied by this over 1.
So the
Go ahead, Alex.
squared can cancel.
With,
X squared.
yeah. No. This can cancel with one of those. So we end up with X. Next up.
Well, you still have 4, right?
Oh, I still my 4. So sorry.
So you divide Can you divide that whole thing by 4 then, or at least?
Yeah, I can kinda go like that.
No, can you do 108 divided by 4?
No, I mean, I guess I could, but then this would be over 4. I mean, you could do that.
Should we put the x back in?
Yeah, let's distribute the x back in. Basically, after this is simplified, what do I need to do with my volume equation? I need to take its what?
Derivative.
I need to take its derivative.
It's gonna be 2x.
Do you want to divide each of these by 4? It's perfectly fine with me.
Yeah.
Okay, what is 108 divided by 4?
27.
Okay? So it's 27x minus, now, this is something else that I need for you to be able to recognize. I need for you to see that I am not going to write this as x cubed over 4. I'm going to write it as 1/4 x cubed. It will make it a lot easier to take the derivative. Okay? Now all you do is say v prime derivative equals
27 minus 3/4 x squared.
and what do we do to find the maximum of this? What do I do with that equation? Set it equal to 0. Okay.
And then we select the second division equation,
Well, let's solve for it first, and let's see what values we get. Okay? All right, so first thing you're going to do, subtract the 27. Multiply by a negative 4/3. Squared equals 36.
What's the square root of that?
All right.
Yup.
Okay, so now what we're going to do is, so now you take a look at this and you ask yourself, which one is feasible? Positive or negative? Probably the positive, right?
I mean, we could make a negative box.
I got big brain. I was right on.